This can be also be using new dissimilarity measures. Some other dissimilarity measures can also be there in terms of categorical data. You can also use a frequency-based method to update modes of clusters. So frequency method can be also used, and mixture of categorical and numerical can be there, which is known as K-prototype method, which is a mixed method. So what is the main problem? Instead of taking the mean value of the object in a cluster as a reference point, medoids can be used, which is most centrally located. So this is, instead of mean, we are trying to transform it in the form of most centrally located part of the cluster or the object in the cluster. So you can see this was the first one, and here based on the most central location, we have reallocated or created the cluster. So this K-medoids clustering method, you can see this is medoids method also, or PAM method also. So we start from an initial set of medoids, and iteratively again and again based on different iteration, you will see replacements are done. So if this improves the total distance of the resulting cluster. So each time you replace the one particular point as the middle point, the cluster also changes. So this work effectively for small data sets, but may not be suitable for very large data sets. So this is something which is very important. Some other studies also have been done by Kaufman and Rochow and NG and Han, which we can see in the form of Clara and Clarence. And this requires focusing and spatial data structure, which was also studied by Esther. So this is a typical PAM method. You can see arbitrarily we have chosen objects as initial medoids, and then we have reallocated them. So we have assigned each remaining object. So after allocation of one point as a center, the other points are also reallocated based on the location of the middle point. So you can see we have first allocated this as the middle points. Now we have made the cluster out of it. Then you randomly select a non-medoid object, O, and then you try to reform that cluster. So again you compute the total cost of swapping. So once you do it, you will find another type of cluster is forming. So this is going for a loop, one iteration, second iteration, third iteration. This is continuous. So this method, as I was mentioning, it was developed by Kaufman and Roche, and it was built in S+ software. So it used real object to represent the cluster. So we selected the K representative objects arbitrarily, and then for each pair of non-selected object H and selected object, we calculated the total swapping cost. So swapping cost is very important. If swapping cost is increasing, so that means you have to stop swapping. But if it is decreasing, you have to continue. So we will repeat the steps until there is no change. So when you find that swapping cost remains same even after one iteration, so that is the point of stoppage. And that cluster is considered as a main cluster. So this is how you do that particular method. So we have taken the first part. You can see two clusters are there. And there was a swapping, and then this total swapping cost was calculated. And then they find that the total swapping cost again and again and again and again. You can see the first part, second part, and third part, and the last fourth part, you can see the swapping cost comes at 0. So this is the point of stoppage. You cannot continue. So whatever cluster is formed here, that is considered as the cluster for future implementation. So this is one of the main problems. So it is more robust than K-means. It is better than K-means in the presence of noise and outliers, because a medoid is less influenced by outliers or other extreme values. It works efficiently for small data sets, but for larger data set, it can be a big problem. So there are other methods which are used if this doesn't work, which is, as I mentioned, the Clara method. So it draws multiple samples of data sets. Here you are applying PAM also, but you are giving the best clustering as the output. So its strengths, it deals with larger data sets than PAM. So in this Clara method, we can use the more elements and more iterations can be done. So efficient SE depends on sample size. How much sample size is there? If it is maybe 4,000, 5,000, 7,000. So again, it depends on how much sample size is there. So a good clustering is based on samples will not necessarily represent a good clustering of the whole data set. So if it is biased, then it is of no usage until and unless if it is random, then it can be continued. So you can see this particular method, which was developed in 1994. So this is another clustering algorithm based on randomized search. So again, it draws sample from neighbors dynamically. So every time you form cluster, you draw samples. So this clustering process can be presented in as a searching a graph where every node is potential solution. So here you can consider every other point around that node as a potential solution. So if the local optimum is found, this starts with a randomly selected node in search for a new local optimum. So it keeps selecting for the most localized part, and then the clusters are found. So it is more efficient and scalable than both Plum and Clara. So here you can focus on techniques and spatial access structures may further improve its performance. So this is hierarchical clustering, as I was mentioning, that you can form different kind of clusters based on distance matrix. So you can, this method does not require number of clusters as input, but needs termination conditions. So there are conditions. So you can see, first we started with A, B, C, D, E, then we divided it into different parts, A, B, C, D, E. Then we have made two clusters, A, B, C, D, E. AB one cluster, CDE another cluster. And CDE has been divided into many parts like DE part, or you can DE and C. So you can see CDE has been divided into C and D. And DE has been divided into D and E. Similarly, AB cluster has been divided into A and B. So this is hierarchical clustering. So there is another clustering which is known as agglomerative clustering. So it was introduced in Kaufman and Roche in 1996. So this method is implemented in statistical analysis packages. It uses a single link method and dissimilarity matrix, as we have mentioned before. So we can use dendrogram also. Dendrogram is graphical representation of the several levels of graphical partitioning, like a tree of clusters. So clustering of the data object is mentioned by cutting the dendrogram at desired level. Then each connected components form a cluster. So you can see we have divided it into different parts, and all these connected points form the part of the main cluster. So Diana method is also there. It was introduced in 1990 by Kaufman and Roche, and it was implemented in statistical analysis packages S+. So it is inverse order of Agnes. So it eventually you will find each node forms a cluster on its own. So you will find that even a single node, since it is more of a divisive kind of technique, so you want to find out the actual results or the most important nodes rather than clusters. So you can find even single nodes can form their own cluster. So you can see from the main clusters, this final cluster, even a single node has formed its cluster of its own. So there are different recent hierarchical clustering methods. One of the major weakness of agglomerative clustering, it does not scale well. Time complexity can be there. It can never undo what was done previously. So there can be integration of hierarchical with other distance-based clustering method like PESH, which also used the CF tree and incrementally adjust the quality of clusters. ROC study was also there, which was a clustering categorical data with neighbor and link analysis. Chameleon also studied hierarchical clustering using dynamic modeling. So clustering high dimensional data can be there. So based on text documents, DNA microdata array, some of the challenges, many irrelevant dimensions can also be there. Distance measurement become meaningless in some cases. Wastage of time and resource can be there. Clusters may exist only in some subspaces because you have to tackle too much data. So that can be a big problem. Methods, as I mentioned, it can feature transformation, it can be PCA, principal component analysis, or support vector machines can also be there, or SPD machines are also there, which can be used to find data which are highly correlated or redundant. Feature selection method can be there, which are wrapper or filter approaches can be there. It is useful to find subspaces where the data have nice clusters. So you want to find space in a big cluster which has more of a real clusters, which is having real quality. Subspace clustering can be there, which can be used for finding clusters in all possible subplaces. And there can be other methods like click, proclus, and frequent pattern based methods. So the dimensionality curse is there. So we know that if we add too much dimension, there can be too much stretch. So that can lead maybe formation of certain clusters which are not so important. So adding more dimensions will make the points further apart. So like these were the four clusters which were created, but the more dimensions we kept on adding, 1 plus 1, 1 plus 2, more and more dimensions. So data became increasingly sparse. So this distance measurement becomes meaningless if we add too much dimensions to it. So subspace clustering, if you can see, it was adapted from Parsons. So clusters may exist in only in some subspaces. We need to find the right subspace and not each and every subspace. So this is how dimension A, dimension B, dimension C. You can see 3 dimensions, but here we are combining dimensions A and B, here B and C, and here A and C. So these two have been combined here. These two have been combined here, and first and third one has been combined here. Now outliers is also very important. So these are certain objects which are dissimilar to all the other points which are there, like in sports, Michael Jordan, Wayne Gretzky. So maybe certain things are there which are quite dissimilar from others. So it is very difficult to tackle those things. One of the major applications can be credit card fraud detection. So it is very difficult to understand that whether there is a fraud using credit card or not. But it is one of the major applications also. Telecom fraud detection can also be there. Customer segmentation, it is a concurrent problem of every company. Medical analysis, identifying different types of diseases and the patterns of diseases which are occurring or abnormalities. So there are different statistical approaches which are there, which are again based on data values. You can see 95% confidence limit we have taken. So that means 5% is left. So it can be 2.5% on the left side and 2.5% on the right side. So this is outlier discovery, how we can do this. You can conduct a discordancy test depending on 3 things: data distribution parameter, that is based on mean and variance. And then you can take number of expected outliers. But again, the drawbacks are there. Most tests are for single attribute. So one attribute based outlier can be taken. But again, it cannot be every time. So every time that for every attribute, there can be different outliers. So again, the problem can be too much complex. In many cases, data distribution may still be unknown. So as I was mentioning, there are different algorithms which are there. So it was mainly introduced to counter the limitation of imposed statistical methods. So many errors used to come up in different algorithms. So they found algorithms for mining distance-based outliers, like index-based algorithm, nested loop algorithm, and cell-based algorithm. So density algorithm was created where you want to find the local outlier factor. So assume outlier is not Chris. Each point has its own LOF. So this is that means a local identification must be there for each subspace. So in this subspace, you can see this is outlier. So we have identified that in this example, C1 contains 400 loosely distributed points, C2 has 100 tightly condensed, 2 outlier points, O1 and O2. So you can see O1 and O2. So this is the outlier part. So the summary, cluster analysis group objects are based on similarity and has wide applications we have seen. So measure of similarity can be computed for various types of data. Clustering algorithms can be categorized into partitioning methods, hierarchical methods, density-based methods, grid-based methods, and model-based methods. Outlier detection and analysis are very useful for fraud detection, etc., and can be performed by statistical distance-based or deviation-based approaches. So there are still a lot of research issues on cluster analysis. So these are some of the references we have used to understand this particular problems. So thanks to all. Please like, comment, and subscribe my channel. And this is a link for the channel. Please do subscribe it and keep watching more videos. Thanks to all. Thanks to everyone. Take care.